Hey guys, welcome back. Let's talk about formal charge. It's the formal charge of an atom. This is not an actual charge, this is a formal charge. The formal charge of an atom is the charge it would have if all the bonding electrons were shared equally between the bonded atoms. I know we talked about electronegativity and the unequal sharing. We're just going to say that if I have two atoms, if I have X bonded to Y, and we have a double bond. Let's talk about a double bond. And orange electrons over here, and purple electrons over here. So it could be like O2, but just in case, we have X bonded to Y, and we have a double bond. What we're saying is, if we're sharing the bonded electrons evenly. So what that means is that there's X, one of these electrons came from X in each bond, and one of the electrons came from Y in each bond to make the bond. Now, it's not always true. There's something called a coordinate covalent bond that we will get to later on, but we don't really need to worry about that at this point. So a coordinate covalent bond is when one atom comes in and donates both electrons to make the bond. Right now, usually, we're saying that X has its 6 valence electrons, Y has its 6 valence electrons, like O2 or OS or OSE, something like that. What we're doing is we're going to break apart this bond. Again, we're not really breaking the bond. We're just going to show that the orange electrons go back to the X and the Y electrons go back to the Y. The purple go to the Y. So that tells us now if X has 6 valence electrons, 1, 2, 3, 4, 5, 6, and it brought in 6 valence electrons, it would have no charge. If X, let's say, brought in 5 valence electrons, like nitrogen, and it has 6 valence electrons, it would be -1. Okay, so hopefully we're going to do 2 examples of this so that we can see it, and we'll use formal charge from now on. When we talk about formal charge, our book tells us to minimize formal charge if possible. So we will always minimize it to get to 0 if we can. The formal charge, this is kind of important, the formal charge adds up to actual charge. So like N2O here, when we do this example of N2O, nitrous oxide, the charges will add up to 0. For SCN, they'll add up to -1. The more electronegative atom tends to be negative. That's not always the case. It's not an absolute. However, it tends to be negative. So let's start with N2O. Starting with N2O, we have valence electron count of 5 for nitrogen, and there's 2 of them. Oxygen is 6, so that gives us 16 electrons. Now the next question is, how is it laid out? Well, most of the time, my students will go N-O-N, because there's 1 oxygen. And okay, well, let's try it. And we'll try it. We will get orange here. 2, 4, 6, 8, 10, 12, 14, 16. Is that a good Lewis structure? Well, oxygen only has 2, 4. So I would say that's a very bad Lewis structure at the moment. What should we do? Well, first thing that comes to mind would be double bond both sides. Perfect. Now everybody has 8. Let's do the formal charges. So nitrogen has 1, 2, 3, 4, 5, 6. It has 6 valence electrons. Nitrogen brings in 5, so it gained 1. So technically speaking, nitrogen's formally -1. Oxygen has 1, 2, 3, 4. It has 4 valence electrons. Oxygen is technically minus 2 because oxygen brought in 6 valence electrons. So if I brought in 6 and now I only have 4, I'm down 2. So I'm plus 2 electrons. I'm plus 2 charge, minus I'm down 2 electrons. Nitrogen has 1, 2, 3, 4, 5, 6. Just like the other nitrogen, it's minus 1. It has 6, brought in 5, minus 1. Now, if we look at our electronegativity charts, if we remember our top 5, fluorine's number 1, oxygen's number 2. Oxygen's definitely not happy here. Do you think this is the best Lewis structure? Well, at this point in the class, I would always say, guys, how do we tell the central atom? Well, it's usually written first and the less electronegative. Oxygen's written second, and it's the most electronegative. So let's try making an N in the middle. So I'll do a blue one, N, N, O, and we'll add to this. So let's use purple. 2, 4, 6, 8, 10, 12, 14, 16. So now, N in the middle is not good. What do? We have options. In fact, how many options do we have? I could double bond both sides. I could triple bond the ends, or I could triple bond the O and O. There's 3 options. So we'll do 3 options. N, O, and N, O. So in purple up here, the blue one, let's double bond both sides. In green, let's triple bond the end. 2, 4, 6, 8, 10, 12, 14, 16. And in light blue, triple bond the O. 2, 4, 6, 8, 10, 12, 14, 16. So now I have 3 valid Lewis structures. And technically speaking, these 3 are all unequivalent resonance structures. This is technically an isomer. It is the same 3 atoms, but it's built differently. Not the same compound. It would have a different melting point, different boiling point, different physical and chemical properties. All right, so now how do I tell if the blue, green, or light blue, if they are, which one's right? Which one's now, when I say which one's right, which one's the most accurate? Because there's equivalent resonance structures like we did before in a previous video, and then there's unequivalent resonance structures like these. And so we'll use formal charge to predict which is the best Lewis structure. Nitrogen, blue nitrogen on the left here. 1, 2, 3, 4, 5, 6. Has 6, brought in 5, it's minus 1. Nitrogen in the middle. 1, 2, 3, 4. In fact, all the nitrogens in the middle have 4, don't we? So if it has 4, brought in 5, it is plus 1. So all the nitrogens are plus 1 in the middle. So the middle nitrogen is the same for each option we have. Then we have oxygen. 1, 2, 3, 4, 5, 6. It has 6, brought in 6, it's 0. Green. 1, 2, 3, 4, 5. Has 5, brought in 5, it is 0. Oxygen green. 1, 2, 3, 4, 5, 6, 7. It has 7, brought in 6, so therefore it is minus 1. It gained an electron. Light blue. 1, 2, 3, 4, 5, 6, 7. Nitrogen has 7. It brought in 5. It gained 2 electrons, so it's minus 2. Light blue oxygen. 1, 2, 3, 4, 5. It has 5 electrons. It brought in 6, so it lost an electron, so that means it's plus 1. So now looking at this, which one is probably going to be the best? Right? Which one has the most electronegative atom negative and the best formal, the minimal formal charge? Which one has the worst? So the light blue is probably the least favorable. We'll call it the worst. Because oxygen's +1, nitrogen's -2, we're not minimized formal charge, it's not minimized. And green is probably going to be the best because we have a minimized formal charge and the more electronegative atom of oxygen is -1. Blue's not bad. Blue's not bad, but oxygen's more electronegative. So it's 1, 2, 3 in terms of, best to worst. Let's look at SCN. So we have electron count, 6 electrons. Oh, didn't switch to purple. 6 electrons plus 4 electrons plus 5 electrons plus 1 electron. That would give us 16 electrons as well. It's bonded just like it's weighted. So we'll do, there's 3 resonance structures, as you can probably guess. And the reason you could probably guess that is it's the same electron count as these 3. It's 3 atoms with 16 electrons. So we're probably going to have the same setup here. Well, let's try it. We'll start with green first. S, C, and N. And then we'll do a blue. S, C, and N. And then we'll do a orange. S, C, N. So for green, bond 2, 4, 6, 8, 10, 12, 14, 16. And that's right. We can do either double bond both sides, single bond the S, or single bond the N. Triple bond the N, triple bond the S. So let's do it. So in the green, we'll just double bond each side. In blue, let's single bond the S. So we got 2, 4, 6, 8, 10, 12, 14, 16. So I'm going to make this a triple bond. And then down here in orange, I'll make this one the triple bond. So we have 1 pair of electrons there, and then 3 pairs of electrons here. All right, let's do formal charge, because that's what's next. And we can use, I'll use this color. So sulfur, 1, 2, 3, 4, 5, 6. It has 6. It brought in 6. No formal charge. Carbon, 1, 2, 3, 4. Has 4, brought in 4. No charge. In fact, that's going to be nice for carbon all the way down. Nitrogen, 1, 2, 3, 4, 5, 6. Nitrogen has 6. It brought in 5, so it's -1. The blue one. Sulfur has 1, 2, 3, 4, 5, 6, 7. Sulfur has 7. It brought in 6, so sulfur is -1. Carbon, 1, 2, 3, 4. Has 4, 0. Nitrogen, 1, 2, 3, 4, 5. It has 5. Brought in 5. It's 0. Well, the green and the blue look pretty good, don't they? Orange, 1, 2, 3, 4, 5. Sulfur has 5. It brought in 6. So that means sulfur is +1. Carbon, 1, 2, 3, 4. It's 0 because it brought in 4. Nitrogen, 1, 2, 3, 4, 5, 6, 7. It has 7. It brought in 5. It is -2. So which one's probably the worst? Well, this is probably the worst. Least favorable resonance structure. Which one's the best? Well, I got 2 of them that are pretty close. Right? And again, why is the orange one the worst? Because I have 2 atoms with a formal charge versus the blue and the green, there's only one atom with a formal charge. That's better. So is sulfur -1 better or nitrogen -1 better? How would I know? Well, who's more electronegative? Nitrogen. So this is probably the best. This is number 2. And then finally number 3. So that's formal charge. They're all technically unequivalent resonance structures, but we want the best one. And in Chem 1, our goal is to find the best one, because most of the time that's what we're going to be looking at. Hope that makes sense.